Hello guys, welcome back to my YouTube channel. Today I am going to solve day 10 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 786, kth smallest prime fraction. Okay, so I am going to treat this problem as hard level. Actually a LeetCode mark this as medium level, but it's a little bit hard. Okay, so let's read the problem statement first. So in this problem, we have given a sorted integer array containing 1 and prime numbers where all the integers of array are unique, and you are also given an integer k. Okay, so for every I and j where 0 is less than equal to I and I is less than j and j is less than array dot length. Okay, we consider the fraction array of I, array of j. Okay, we have to return the kth smallest fraction considered, and we have to return your answers as an array of integers of size 2 where answer of 0 is equal to array of I and answer of 1 is equal to array of j. Okay, so this is example 1 given to us. Okay, this is an array given to us. It is in increasing order and all the values are unique, right? And the fractions to be considered in sorted order are 1 by 5, 1 by 3, then 2 by 5, 1 by 2, 3 by 5 and 2 by 3. Okay, so these fractions are in sorted order. Okay, and k is equal to 3 simply means that we have to return the third fraction. Okay, so 1 2 3, third fraction is 2 by 5, so we are returning this here. Okay, so this 2 is nothing but my array of I and this 5 is nothing but my array of j. Okay, so we have to return the answer as answer of size 2. Okay, where answer of 0 is nothing but my array of I and answer of 1 is nothing but my array of j. Okay, so now let's understand this problem, how I'm going to solve this problem. Okay, but before starting here, let's write some few things like what is the my length of array. So int n is equal to array dot length. Okay, this is going to give me the length of array, and we have to return one result, right? Result array, and we already know that what is the size of my result array. It is nothing but 2, right? So this is my result array and the size of my result is 2, right? So I'm going to write it like this, new int 2. Okay, this is done. Okay, so now let's understand this problem with an example. So let me copy this example here, this example 1 given to us. Okay, so this is the example, right? So here, okay, so actually we are taking the fractions, right? We are taking the fractions. So for this number 1, what are the different fractions that I can take? Because I know that my I is less than j. Okay, so for 1 I can take these fractions, right? 1 by 2 and 1 by 3 and 1 by 5. Okay, these are the fractions that I can take for a number 1. Okay, and for number 2, how many fractions can I take? 2 by 3. Okay, and then 2 by 5. Okay, these are the fractions that I can take. And for number 3, how many fractions can I take? 3 by 5. This is the only one, right? Right, this is the only fraction that I can take, 3 by 5, and that's it, right? So here we have to calculate the fractions like this of all the numbers. Okay, so for 1 by 2, can I write it like this? 0 0.5, 1.5, 1 by 2 is 0 0.5, and what is the value of 1 by 3? Okay, so what is the value of 1 by 3? So I think it is going to be 0 by 0.1 divided by 3 is equal to 0.33. Okay, I am using calculator right now, okay, for saving time. And 1 divided by 5 is equal to 0.2. And what is the value of 2 divided by 3? It is nothing but 0.66, right? 0.66. And what is the value of 2 divided by 5? It is nothing but 0.4. And what is the value of 3 divided by 5? So this value is nothing but 0.6. Okay, 0.6. Okay, so 1.5 is 0.2, right? So first I am writing this 1.5. Okay, this is a minimum, 0.2. Then after 0.2 we have 0.33. okay, that is why I am writing it in the second position. Okay, then 0.33, this 2 by 5 is coming, right, after 0.33, so that is why I am writing 2 by 5 here. And after this 0.4, this 0.5 is coming, right? So I'm writing 1 by 2 here, and then 0.6 is coming. Okay, so I am writing this here 3 by 5, and then 0.6 by 6 is coming, then I am writing 2 by 3 here. Okay, and k is equal to 3 simply means that we have to return this third one. Okay, so I hope that this example is clear. Okay, so now how I am going to solve this problem. Okay, so I am going to use binary search. Okay, so so if I divide a number by itself, okay, if I divide a number by itself, then what is the maximum fraction that I get? 1, right? If I divide a number by itself, then what is the maximum fraction that I'm going to get is 1 only. Okay, so I'm going to create two variables. One is high and one is low. Okay, and the value of high that I'm going to give is 1.0, and the value of low that I'm going to give is nothing but 0.0. Okay, so here let's create two variables as well. Double low is equal to 0.0 and high is equal to 1.0. Okay, so I have created two variables. Okay, now after that I am going to run one while loop. Okay, after that I am going to run one while loop while my low is less than high. Okay, while my low is less than high, I am going to run one while loop. Okay, so here this is an array given to us, right? Array is equal to 1 2 3 5, right? Array, let me just little bit minimize, right? So now it is clear. So array is 1 2 3 5. Okay, so now initially let's take okay, so first, our low is 0.0, our high is 1.0. Okay, so what is my mid? What is my mid? Somewhere here, right? Mid, and the value of mid is nothing but 0.0 plus 1.0 divided by 2 is 0.5. Okay, this is my mid. Okay, this is clear. This is going to be my mid, right? So here just write this mid as well. So inside this I am calculating my mid as well. Okay, this I am explaining line by line because it is easy to understand then. Okay, mid is equal to low plus high divided by 2. Okay, this is going to be give me the mid. Okay, so now after that I am going to create one variable count. Okay, and the count is going to give me the number of fractions which are less than or equal to my 0.5, my mid. Okay, so what I am saying here, I am going to create one variable count. Okay, I am going to create one variable count which is going to give me the number of fractions which are less than or equal to my mid. Okay, so I am going to create one variable count. Okay, so let's create one variable count and initially give the value as 0. Int count is equal to 0. Okay, this is done, and let's create one variable double, okay, which is going to store the max fraction that we have encountered so far. Max fraction, so max fraction is equal to 0.0 right now. Okay, this is what I'm giving, and also I'm starting from this first position now. So my j is greater than I always. Okay, so here what I'm going to do, I am going to write int j is equal to 1. Okay, j is equal to 1. Then after that I have to start from this position, right? From starting, for my I is this one, then my I is this one, then my I is this one, and j is this one. Okay, but I can't take the fraction like this 5 by 5. I can't take this fraction. Okay, so I'm going to run my I till here only, till 3 only. Okay, because I don't want to run for 5 by 5, right? I don't want to do this. So for int I is equal to 0, I is less than n minus 1, and I plus plus. Okay, this is my for loop. Okay, and inside this for loop, okay, I have to write few lines. Okay, so first let's understand. Okay, so this is clear. Okay, So now initially my I is at this position and j is at this position. Okay, so what I'm saying here, my I is at this position and j is at this position. Okay, so when I do my array of I divided by array of j, okay, in double format. Okay, in double means just I'm writing here double array of I divided by array of j. Okay, when I'm doing this, okay, so what is the value that I'm getting? I'm getting 1 by 2 is equal to 0.5. I'm getting 0.55, right? And 0.5 is greater than mid. Tell me that this 0.5 that I'm getting here by dividing 1 and 2, it is greater than mid or not? It is not greater than mid, right? Because it is its value same as of this mid only, 0.5. Okay, 1 divided by 2 is nothing but 0.5, and this value is not greater than this mid, right? So after that, okay, we know that all the values are in increasing order. Okay, so after that, if I do okay, so just understand like this only. Okay, so 1 divided by 2 I am doing, and I am getting some value that is nothing but 0.5. Okay, so here let's write the line first. Okay, for better understanding, let's write the line. Okay, so one while condition, in the while condition I am checking while my j value is less than n. Okay, so definitely my j is going to run until my j is less than n, right? And after that, double of array of I divided by array of j. Okay, if this value is greater than mid. Okay, if this condition is true. Okay, if the array of I and array of j value is greater than mid, then I don't want to find that. Okay, I don't want to search that. I'm just incrementing the value of j. Okay, incrementing the value of j. But here, when I'm dividing 1 with 2, I'm getting the value as 0.5, and this value is not greater than 0.5. Okay, so I'm not incrementing j right now. Okay, because it is clear that if 1 by 2 is giving me 0.5, if 1 by 2 is giving me 0.5, then definitely all the other values, okay, all the other values like this 1 by 3 and 1 by 5, all the values are going to be less than 0.5, right? So what is the 1 by 3 is nothing but 0.33, and what is 1 by 5? 0.2. Okay, so we know that this is in increasing order. We know that in the array of I is sorted and all the values are in increasing order, and here only if 1 by 2 I have found that the value is coming as 0.5, and 0.5 is here, lying here. Okay, just above this mid, right? And my count is going to give me the number of values, number of fractions which are less than equal to my mid. Okay, so how many fractions that are less than my mid or less than or equal to my mid? 3 fractions, right? These 3 fractions are less than equal to mid. Okay, I hope that this line is clear. Count is just used to store the number of fractions which are less than equal to mid, right? Right. So here what I'm going to write after this while loop, count is equal to count plus n minus j. So it is going to give me 3, right? Count is 0 initially, n is 4, size of this array is 4, minus j, j is 1, right? Because we didn't execute anything inside this. Okay, we didn't increment the value of j's here, right? Okay, because this condition become false now. Double of array of I is 1 and 2 is greater than the mid. No, it is equal to mid. It is not greater than mid. Okay, so we are not executing anything inside this while loop. Okay, so directly we get the count as count plus n minus j, and that's true because there are total 3 fractions. There are total 3 fractions which are less than equal to mid, right? And here, okay, so I hope that this is clear. And there is one base condition. If my n, if the value of my j becomes my n, then in that case just simply break now. Just simply break. Okay, so right now my j is 1. Okay, so we are good. But if my j is 4, okay, that is out of loop, right? Out of this array. Okay, this is 0th index, first index, second index, third index, fourth index. So if my j is equal to 4, okay, and that is not possible, so simply return it. Okay, why I am saying this, we will get to know in few minutes. Okay, why I am writing this base condition. Okay, so but I hope that this line is clear. Okay, what this count is giving. Okay, so this is done. Now let's do one thing. Let's update the max fraction. Let's update the max fraction that I have encountered. Okay, what is the max fraction right now? So for that, I am creating one variable double fraction is equal to double of array of I, array of j. Okay, this is how we are calculating the fraction, right? Array of I, array of j. And here inside this, I am writing if my fraction, if this fraction is greater than my max fraction, is greater than my max fraction, then I am updating my max fraction as my fraction, and result of 0 is going to be the upper part, that is going to be my answer of I, array of I. I am going to write it array of I, and my result of 1 is going to be my array of j. Okay, this is what we need to find, and right. So this is clear. I hope that this is clear. This is where we are storing the max fraction that we have encountered so far. Okay, so this line is clear, right? So my I is here. Okay, so let me write it like this: 1, 2, 3, 5. My I is here, my j is here. Okay, then I have checked 1 divided by 2 is 0.5. Okay, and this 0.5 is not greater than mid. Okay, it is equal to mid, so we don't executing this line. And then after that, I have checked if j is equal to n, then we are breaking. Okay, so here a count is going to be the number of fractions which are less than equal to mid. Okay, that's right. And here I have stored the max fraction. Okay, result 0 is 1, result 1 is 2. Okay, this is done. Then after that, my I will become 1. Okay, then in the next loop my I will become 1. Okay, this is done. Okay, this is done. Then again my for loop will execute now. So my for loop, now my I will become 1 here. Okay, I reaches at this position and j is at this position. So right now, when I do this 2 divided by 2, okay, so both I and j are both at same position. So this condition is true, but this condition is false, right? This condition is also true. This condition is true. This condition is also true. Array of I is 2, array of j is 2, 2 divided by 2 is 1, and 1 is greater than mid. What is the value of my mid? Mid value is 0.5. This condition is true, so my j will be incremented. Okay, so now my j reaches at this position. Okay, now after that, again I'm this is while loop na. Again I'm checking array of I. What is the value of my array of I? Array of I value is 2, and what is the value of array of j? Array of j value is 3. So 2 divided by 3 is nothing but 0.6, and 0.66 is greater than my mid 0.5. Okay, so again my j will be incremented. Okay, again my j will be incremented, so j reaches at this position. Okay, now I'm going to do 2 divided by 5. Okay, so now listen carefully. 2 divided by 5. What is the value of 2 divided by 5? 0.4, and 0.4 is less than mid. Okay, this condition is false, so I'm not going to increment my j. Okay, now I am going to check if j is equal to n. So what is my j? My j value is nothing but j is at this position now. J value is at this position, 3, third index. Okay, so j is not equal to n. N is 4 now. So now my count is count plus. So what was the old count? Old count was 3, right? We are running inside the same for loop now. So previously my count was 3. 3 plus 4 minus j. J is 3 this time. J is 3 this time. So I have incremented 1. Right? So count becomes 4 here. Now count becomes 4. Okay, previously count was 3 and now total n we know 4, and this time j was at this position 3, so my count is 4. Okay, and that is true. We have found one more fraction, na? We have found one more fraction, 2 divided by 5, which is less than my mid. Okay, so 2 by 5 is also less than mid. 2 by 5 is also less than mid. What is the value of 2.5? 0.4. Okay, so there are total 4 fractions which are less than mid. There are total 4 fractions which are less than mid. I have found 4 fractions which are less than mid. Okay, so one thing is clear. I want to search for k is equal to 3, and we have already encountered 4 fractions which are less than mid. So definitely my k is lying somewhere here. K is lying somewhere here. Okay. Okay, so I hope that this statement is clear. What I am saying, this is my low, this is my high, this is mid 0.5, and I have already found that there are 4 fractions in this range, and I have to search for the third, k is equal to 3. So definitely why I am searching here, I don't need to search anything here. I have to search inside this window only, right? For k I have to search inside this window only. Okay, so here I am going to write few more lines in the code specifically for this one. Okay, so what I'm going to write here. Okay, so here we have already updated our result 1 as array of j. Okay, this is done. Then this is done here. For loop completed here, and now after that, inside this my while loop, I am going to check if my count value is equal to k. Okay, if this value is equal to k only, if count is k only. Okay, but right now I didn't come outside the my for loop. Okay, I didn't come outside my for loop right now. Okay, so this is what we have found. 2 divided by 5 is 0.4, and 0.4 is less than mid. Okay, this is what I found, and count becomes 4. Again I am checking the fraction here. Okay, just forget this part right now. I am checking the fraction after that. So 2 divided by 4 is 2 divided by 5 is 0.4, and previously max fraction was 0.5 na, 1 divided by 2 when we did 0.5. So I don't need to update this part. I don't need to update this part. Okay, so now this 2 by 5 is done. 2 by 5 is done. Now after that my I is going to reach at this position. Okay, now I is at this position, and then I'm going to do 3 divided by 5. 3 divided by 5 is 0.6. 0.6 is greater than my mid. 0.6 is greater than my mid, right? So j plus plus, so j becomes 4. J becomes 4. J becomes 4, right? Now j becomes 4. So here I am checking if j is equal to 4, then break. Okay, then I am breaking. So now I am coming outside this while loop. Now I am coming outside this while loop, outside this for loop. Okay, this is where my for loop ends. Okay, now I'm coming outside this for loop, and now I'm checking if my count is equal to k, then simply means just break it. Just break it. We have already got the answer here in my max, in my fraction, result 0 and result 0 and result 1. But if the value of count is less than k, if the value is less than k, and here else part. Okay, so I have already explained here that my k is lying somewhere here, right? My mid is 0.5, and there are total 4 values here, so definitely k is 3 now. So count, so my count is greater than k. So in the else part I am writing some line here in the else part here, line number 31, because my count is greater than k. Count is greater than k. When I come outside this for loop, my count was 4. Okay, then that simply means that my value exists in this part. Okay, so I don't need to search for this part. So what I'm going to do here, I am directly going to update, this was my high now, I'm going to update my mid as high only. Okay, so here I'm going to write as my high. So now my high will become this part. Okay, my high will become this part. Okay, I am going to leave this part. I don't need to search. Okay, high is equal to mid. But if let's suppose if this value is less than k. Okay, if my count is less than k, definitely then my values are lying here. So then in that case I am just going to update my low as mid. Okay, that's what this is. Simple for a while, this is simple binary search, right? Low is equal to mid. This is what, this is how I am searching, right? Okay, so I hope that this is clear, and in the end I am just going to return one result. Okay, so I hope that these lines are clear. Okay, so this is done. So now next time my low becomes 0.0 only. Okay, and my okay, and my mid becomes 0. My high becomes 0.5. Okay, high becomes 0.5 and low becomes 0.0, then mid becomes 0.25. Okay, then I'm going to search for values in between those. But I hope that this part is clear what I'm doing here. Okay, so if I run the code, let's see what happens. So see, all the test cases has been accepted, but don't worry, I'm again going to explain few more things. But see here, all the test cases has been accepted. Okay, and let me submit it. So see, our solution is accepted, and runtime is just 4 milliseconds, and it beats 90% of users with Java. Okay, so code is this part only. Okay, how many lines? 37 lines, I think. 37 or 36. Okay, let me reduce this space. Let me remove this. Okay, let's leave it. Okay, 36 lines. Just 36 lines. Okay, see, code is very simple. Code is very simple. I hope that you guys are clear what I am doing here. Okay, so I have explained just first iteration for my when my low was 0.0 and high was 1.0 and mid was 0.5. I have explained that. Okay, so now see here I have explained in detail. Okay, I have debugged the code, what is happening. Okay, so I have explained this part already. If you see, I have explained this part already, right? So you guys can do one thing here. You guys can also write the system.out.println lines for more better understanding. Okay, so I have added all these lines here, so you guys can also debug the code like this. Okay, so here I have added all the system.out.println lines. Okay, so see here, now let's go one more time what is happening. Okay, low in the starting 0.0, high was 1.0, then my mid becomes 0.5, and inside for loop my I is 0 and j is 1. Okay, so let's do one thing here. Okay, we have already written the code. Let's copy this example one as well somewhere here. Okay, here let's copy the example here. Okay, this is done. So see, low is 0.0, high is 1.0, then my mid becomes 0.5, then inside for loop my I is at index 0 and j is at index 1. Then I am going to check for while j is less than n and double of this. So see, we didn't execute write this statement incrementing value of j. Okay, we didn't write here because this doesn't execute, because my array of I1 divided by 2 is 0.5 is equal to 0.5. Okay, so that is why we didn't execute this part right now. Then I'm checking for this condition, I is equal to 0, j is equal to 1, and then count is 3. I have already explained why count is 3. Okay, because there are total 3 fractions whose value is less than equal to my mid. Okay, that is why 3. Then we are updating result as 1 by 2. So this is the line update result. Okay, so since my fraction is greater than my expression, okay, that is why I am updating here 1 by 2. Then after that my I become 1. Okay, I become 1 and j is 1. Then I am incrementing it 2 times. Okay, that is I have already explained here. If you see here, j was at this position, then j reaches at this position, then j is at this position. Okay, so after that only I did this 2 divided by 5. Okay, but I have skipped this 2 divided by 2 I have skipped, and 2 divided by 3 I have skipped. Okay, these two things I have skipped. So this is what that is by incrementing value of j, okay, 2 times. Then I1 j is equal to 3, then count becomes 4. This is I have already explained by my count becomes 4 here. Here see, uh, 1 by 2, 1 2 3 4, okay, in the, here I have explained now 4 fractions, okay. So this I have already explained. Count becomes 4, then inside for loop, then increment 2 by 3, then incrementing value of j, I is equal to 2, j is equal to 4, j becomes 4. So here becomes 4, then I am breaking, then I am going to outside the for loop, okay. So here I am writing outside for loop, okay. And then after that I am just lowering the window, okay, lowering the size of window, okay. So that is why my low was at this position, high was at this position, mid was at this position, okay, mid, high was at this position, low was at this position. Then I know that my k exists somewhere here, okay. So what I did, I just modify my mid as high, okay, this will become my high, delete everything. So see here, low is 0.0 only, now my high becomes 0.5, okay, high becomes 0.5. I am not going to search here now, inside here, because I know that my k somewhere exists somewhere in between, okay. So again, mid is equal to 0.25, I have calculated the mid, and again I am going to start count as 0, double max fraction, again I have initialized this value, and j is equal to 1, again I am searching from the start, okay. Then again from 0 to n minus 1, again I am going to run, okay, but this time I am going to compare with this mid 0.25, this mid, okay. So this is the second iteration, this is going to be my third iteration, okay, fourth iterations, okay. And here see, in the end somewhere I am going to get the count as 3, okay. Somewhere I am going to get the count as 3, and the result was 2 and 5, okay. So if you write all these system.out.println lines, you will see, okay, this is what's happening here, 2 by 5. So here when my count is equal to 3, then I'm just going to break, and in the end I'm going to return the result, and in the result I have already stored 2 and 5 here, okay. So I hope that you guys are clear, okay. So actually I have spent a lot of time in all these debug statements, so that you guys can get clear, better understanding what is happening in the code, okay. So I hope that you guys are clear, okay. And since we are using the binary search here, okay, so time complexity is going to be log of n, and inside this I am also iterating over the elements one by one. So I am going to say my time complexity is of n log n, because every time I am reducing the window size as well now. First I am searching in this space, then I am going to search for in this space, then after that I have to search in this space or in this space. That's I have to determine, okay. This is what's happening, right? So time complexity is going to be of n log n, okay. So I hope that you guys are clear with this problem, and if you guys still have any doubts, then please feel free to ask in comment section. And don't forget to like this video, share this video with your friends, colleagues, brothers and sisters, and please subscribe my YouTube channel. I hope that you guys are clear with today's problem, right? And so meet you guys in the next video. Thank you, bye bye.